Okay, so let's try to understand the idea of graphs of functions. So, in the previous classes, we were consecutively talking about functions and transformations of that are included in functions, and this is a very important concept that each and every student must know. But when we are talking about the graphs of functions, what is different as compared to general functions? Let's try to understand this. So, in front of us, what do we have? Okay, have I started recording? Yes, I have. Okay. So, first of all, what we need to understand is that there is something called a linear function. The term linear is derived from the word line. Alright. So, in front of us, what do we have? We have the Cartesian coordinate system that looks like this, and we have a line that is going like this, okay, from one end to the other. Uh, and for example, we have a line that moves like this. We have been given two equations. The first one is y equals to minus 3x plus 2, and the other one is y equals to minus, in fact, no, 4x plus 1. You are told to relate one equation to the other. Which one is which one? So, how do you figure that out? Of course, when you people will be setting for your e assessments and your finals, so you people will have the idea of the rules and the regulations of coordinate geometry. But in case if you don't, you should understand the idea that this red line is representing a negative gradient as it is moving downwards, right? And this blue line represents a positive gradient as it's moving upward as it goes from left to right. If you people don't understand gradient, by default you should, but let's say you people don't. We can see that the positive y-intercept of the red line is more than the positive y-intercept of the blue line. But still, the gradient should be sufficient for you people to understand. So I can say that this line, the red line, is minus 3x plus 2, and the blue line is y equals to 4x plus 1. There are various types of gradients, and we discussed this in coordinate geometry. One of the gradients looks like this. This. This orange line represents the vertical. This vertical line represents a type of a gradient that is infinite. Alright? Imagine this as a bridge on which a car is moving downwards. So this shows infinite gradient. Alright? And then in another circumstance, another type of gradient that we can have is, for instance, a zero gradient. Let me write this down in a more efficient manner. This is what you call the zero gradient. Alright? After that, let's try to understand the idea of quadratic graphs. This is just a general overview of what we have already done in algebra. Now, you know that in order to represent a quadratic equation, there are two methods. The first method is the general method that looks like this: y equals to ax squared plus bx plus c. Alright, we know this. Then There is another method. This is what we call the standard form. After that, we have another method. The second method is y equals a into x minus b whole square plus c. Now, by default, this is not in the standard math MYP syllabus. All right, but this is in the extended part. But this form is known as the completing square. But what is it that the standard students are supposed to know? You see, the coordinates or the values of B and C being represented in such a curve represents the coordinates of the turning point. The coordinates of the turning point of the parabola. Okay, what is a parabola? Let's try to understand this. So, a quadratic graph looks like this. Always remember that a quadratic graph looks like this. It has two, at least it has 2 points of intersection. It may have one as well. At most, I meant that it has 2 points of intersection with the x-axis, and at the same time it has a turning point. Now, in order to find the values of the intersection between the x-axis and the parabola, we solve the equation using the quadratic equation formula and stuff like that, right? But in order to find the value of the turning point of the parabola, we have to convert the equation into the completed square form. So, what do we have in front of us? First, let's try to understand the two types of parabola that we might have. The first one, of course, looks like this, and the second one looks like this. This is the U-shaped parabola, and this is the N-shaped parabola. But what is the difference? The difference is that the U-shaped parabola has a positive x squared in front of it. For example, let's write out an example: 2x squared plus 6x plus 12. Or let's say x squared plus 3x plus 9, for instance. Okay, it can be any example, but the idea is that it has a positive value of a before x squared. So the coefficient of x squared is positive. On the other hand, what about this one? We have a negative value of a before x squared. So it can be, for example, negative x squared plus 5, or negative 3x squared plus 4x plus 8, whatever the value is. So you should understand the difference between the two types of parabola. The x squared term, that which is positive, what type of a shape it creates, and the x squared term which is negative, and what type of a shape it creates. Now you see, both of them are supposed to have turning points. This one has a turning point and this one has a turning point as well. But what is the difference? This turning point is called the minimum point. Minimum. On the other hand, this turning point is called the maximum point. Alright, this is something that each and every one of you should be well aware of. Okay, we know everything in regards to the minimum point or the maximum point, whatever, right? But what do we have next? What are we supposed to do after this? What we're essentially supposed to be doing here is, if there is a question that you might have, find the turning point coordinates. Now this can be done through two methods. Either the standard form of the quadratic equation, which is ax squared plus bx plus c, which requires a little bit of working, or the completed square form that can be represented in the form of a into x minus b whole square plus c. There are two methods to understand. To find the coordinates of the turning point, that will be the minimum or the maximum point. The examiner might refer to you in any way as he or she likes, but you should understand the concept behind it. So, use if we were given this type of an equation, let's say the equation was 2x squared plus 6x plus 12. How do you do it? In order to find the x coordinate of turning point, x coordinate of turning point, we apply the formula x equals to minus b divided by 2a. We apply this formula. So we have the value of a equals to 2, b equals to 6, and c equals to 12. Agreed, right? So what do we have? Minus 6 over 2 multiplied by 2. So this leaves me with an answer of minus 6 over 4, which is minus 1.5. So the x coordinate of the turning point is going to be minus 1.5. I hope this makes sense. Now, since we have the value of the x coordinate of the turning point, it's not too difficult to find the value of the y coordinate of the turning point. What do we have to do? We simply have to substitute the value of minus 1.5 into this equation. So we get 2 multiplied by minus 1.5 whole square plus 6 multiplied by minus 1.5 plus 12. So if we were to solve it on our calculator, let's see what answer are we supposed to get. We will get an answer of 7.5. All right. Now, once we're done with this, if you were told to find the coordinates of the turning point using the completed square form, how would you do it? Have a look. Let's say the equation was given as 2 multiplied by x plus 1.5 whole square plus 7.5. Now you see there's something different. What have I done here? I told you at the very start that when we are using the standard form equation, so there's some amount of working that we have to do. First, we have to find the formula using minus b over 2a. Then we have to, once we're done finding a value of x, then we have to substitute that value in order to find the y coordinate of the turning point. So the total coordinates are minus 1.5 comma 7.5. All right. Now, in this part, in the completed square form part, it's it's pretty straightforward. What do you have to do? You see this value and you see this value. This value represents x, but the only difference is you have to switch the sign. So instead of writing 1.5, you write minus 1.5, and this sign remains as it is. You write 7.5, just like that. If there was an equation given like this: x minus 3 whole square plus 5. So the equation or the coordinate of the turning point would be 3 comma 5. The y coordinate, which is represented by c, it remains as it is, whereas the x coordinate, we'll just take the inverse of it. Nothing else needs to be done. It's very straightforward. All right. Now, how to construct a graph? Before construction of a graph, let me explain the completed square form in a little bit of more detail. Now, by default, this question is not very prevalent in MYP standard maths. It is usually more common in extended mathematics. But I would prefer that standard math students do understand how this process essentially works. So let's say you have an equation 2x squared. Let's start with the one that I usually talk about, plus 6x plus 12. And you are told convert this equation into the form of a into x minus b whole square plus c, like basically the quadratic equation form. How do you do it? Have a look. Look, first, this is my strategy, and my strategy is known as comparing coefficients. Now, this is not essentially a topic, okay? So don't get confused. This is my strategy of solving questions like these. How do I do it? It's plainly simple. You see this equation, a multiplied by x minus b whole square plus c. What will I do? The first thing I'll do is I will expand x minus b whole square. So I'll write this as a into x minus b multiplied by x minus b plus c. First, I will multiply the things that are present already within the bracket. X multiplied by x becomes x squared. X multiplied by b becomes x multiplied by negative b becomes negative bx. Negative b multiplied by x becomes negative bx again. And minus b multiplied by minus b becomes positive b squared plus c. So this becomes a multiplied by x squared minus 2bx plus b squared plus c. Then whatever is inside the bracket will be multiplied by a. So we have ax squared minus 2abx plus ab squared, and the c was outside as it is, right? But you see, where is the benefit of what's the benefit of doing this? Now, since we have expanded the form of completed square, let's just compare our two equations with each other. We had 2x squared plus 6x plus 12, right? Let me compare the x squared term with the x squared term. So if, essentially speaking, both of these values are supposed to be numerically equivalent to each other, right? So I can say that the value of a is going to be 2. Simple as that. Okay. Then what do I have next? X term should be compared with x term. So I can say that minus 2ab should be equal to 6. Don't forget the minus sign. 2ab should be equal to minus 6. The minus sign moves to the other part of the equation. But I already had the value of a as 2. So I will write 2 multiplied by 2, b equals minus 6, 4b equals to minus 6, and the value of b becomes minus 6 over 4, which is minus 1.5. Alright. Now let me compare the non-x terms with the non-x terms. So what do I have here? ab squared plus c should be equal to 12. A is 2, b is minus 1.5 whole square plus c is equal to 12. So if we were to apply this formula, we get 4.5 plus c equals to 12, and c equals 12 minus 4.5, which equals to 7.5. So what answer do we get? We get a into x minus b whole square plus c, right? That was the answer, the original form that we had to represent it, right? So the value of a was 2, the value of b was minus 1.5. So when 2 minus are multiplied with each other, we get a positive value, and plus c remains 7.5. Isn't this the same equation that we had already had above? So have a look. This is one way of comparing coefficients and finding the right answer. Alright, let's try another one. We are told that there is an equation 3x squared plus, let's say, 15x minus 27. We are supposed to convert it into the form of a into x minus b whole square plus c. Let's say, alright? And we're supposed to find the values of a, b, and c. You see the good part. If you memorize this equation, this one, if you memorize this equation, you don't have to solve this equation over and over repeatedly. So, it's only work for the first time. After that, it becomes quite easy. So, let's compare the values with each other. The value of x squared remains x squared as it is. So, a equals to 3. Understood? Now, minus 2ab should be equal to the x term, should be equal to 15. So 2ab equals to negative 15. The value of a was 3. So 2 times 3 into b equals negative 15. 6b equals negative 15. b equals negative 15 divided by 6. This becomes negative 5 over 2. Then we are left with the last one. ab squared plus c equals to negative 27. The value of a is 3. The value of b is going to be minus 5 over 2 whole square plus c should be equal to negative 27. So if we were to apply the formula, we would get c equals minus 27, and this part, when we were to multiply it, we got 18.75, positive 18.75. Now we get negative 18.75 as it moves to the other part of the equation. So you get minus 27 minus 18.75. We get an answer of c equals minus 45.75. So this can be represented as 3 multiplied by x plus 5 over 2 whole square minus 45.75. That's how we solve this part of completing square methods. I hope this makes complete sense to you. Now, how to sketch a quadratic curve. Sketching a quadratic curve. Let's say an equation was given to you in the form of 2x squared minus 12x plus 20. If we were to solve this question and complete this into the standard form, or like this is already a standard form, if we were to convert this into the completed square form, we would get an answer of 2x minus 3 whole square plus 2. But I won't solve it right now, I'll just leave it, okay, because this is what you can do it yourself. We'll just get to the work, what we need to do. Let me do one more thing. Let me take this a bit towards the left. Okay, now you see there is something happening here. Now in front of us we have a positive 2x squared value. Alright? We have a positive 2x squared value. This means that first things first, we know that our graph is supposed to be looking like this. It's supposed to be a U-shaped graph, basically. Like, like this. Then what do we know? We also know that the turning point is going to be 3 comma 2, right? Which means that when the value of x is, let's say, 3, the value of y is supposed to be I'm sorry, the value of x is supposed to be 3 and the value of y is supposed to be 2. So this is essentially supposed to be the turning point of the parabola. So here we go. You can sketch the parabola like this. It looks like this. Alright, that's how we sketch a quadratic curve. Sometimes the examiner might ask you that what is the line of symmetry. So you can say that this is the line of symmetry, which is essentially, my bad, I just messed it up a little bit. The line of symmetry is x equals to positive 3. Then let's try to talk about graphs, other graphs. Other graphs, like the cubic graph, you're not supposed to know this in a lot of detail. You're just supposed to understand how it essentially works. What is a cubic graph? Just like a quadratic graph is a graph that has the highest power of 2 on an x. So on a cubic graph, the highest power is of positive 3. So for example, y equals to x cubed plus 2x squared is an example of a cubic graph. How does a cubic graph look? A cubic graph essentially looks like this. This is how a cubic graph is supposed to look. And this is the graph of y equals to x cubed. But if I want to reciprocate this graph, and if I want to, let's say I introduce a minus sign in front of it. I write it like this: y equals to minus x cubed. How would I write it down as? I would simply assume that there is a line of reflection in the x-axis. So this is how it is going to become. Let me draw it in a more efficient manner a little bit. Somewhat like this. So this is what you call a cubic. Then let's try to understand the idea of reciprocal graphs. Only quadratic graph is in a lot of detail. Otherwise, for the rest of them, you just have to understand the idea of how graphs work. Nothing else. How do reciprocal graphs work? The reciprocal graph essentially looks like this: y equals to 1 over x. So this sort of a graph is called an asymptote. A S Y M P T O T, asymptote. What is an asymptote? Asymptote is basically a line which a graph keeps getting closer and closer, but it can never touch the x or a y axis. So this is what an asymptote looks like. This is a horizontal asymptote, and this is the vertical asymptote. All right, this is how that graph essentially looks. And if you want to write it in a reciprocal form, that looks like this: y equals to, let's say, negative 1 over x. So we just reciprocate. This is how it essentially happens. All right. So that is what we people are supposed to know regarding reciprocal graphs. Adding on, exponential graphs, probably the last one. So how does an exponential graph look? You see, whenever we say that something is increasing by uh, a factor of the exponents, right? Something is increasing by a factor of the exponents. How does it look like? It looks somewhat like this. Y equals, let's say, a raised to the power of x. So exponent by default represents some sort of a power, right? So we have studied indices, but we don't know how their graphs look like. So an example of this can be written as y equals 2 raised to the power of x, or whatever value it is. So the graph is supposed to look like this. This shows some sort of an exponential increase. All right. So what is it essentially showing us? It is showing us that there is an increase happening, but imagine this as an overnight sort of a monumental increase, right? So that's what an exponential graph looks like. Now, how does the question look like? They're going to give you two graphs, exponential graphs, for instance. One looks like this. For example, this is 1, and this is, for example, 2. And then there is another graph that moves like this. And they're going to give you two equations: y equals to 3 raised to the power of x, and y equals to 3 raised to the power of x plus 1. And they're going to tell you, identify which equation is which. Now, how would you do it? The easiest way to do it is by understanding the idea that we learned in indices, that x raised to the power of 0 is 1, right? So, or anything raised to the power of 0 is 1. I know that on the y-axis, the value of x is going to be 0. On the y-axis, the value of x is going to be 0. So, y equals 3 raised to the power of 0. So, essentially, y should be equivalent to 1. So, this first equation that you see represents the black line. And just like that, I know that when the value of x is 0, so that index becomes, that power becomes essentially, base becomes 1. So y equals 1 plus 1 and y equals to 2. So essentially speaking, the second equation represents the red line. One easy strategy that most students tend to miss out on is by understanding the idea that, okay, if there is a point of intersection between the line and the x-axis, so at that point y value should be 0. And if there is a point of intersection between a parabola or any sort of an equation between it and the
y-axis, so at that point x value is going to be 0. So that's how we're going to identify a specific graph. All right. So I hope this idea and